Alright, so here we have the new BrotherHobby Avenger series. These were sent in by BrotherHobby, so thanks BrotherHobby for sending his motors for testing and review, so I can share the results with you guys. Thanks BrotherHobby, I really appreciate that. So these are keeping the Marvel Universe theme, so pretty cool name, I think. So these come in 2507 and 2407 sizes. The ones they sent me were 2507 1800 kV, 2407 1850 kV, 2507 2700 kV, and 2407 2450 kV. So pretty large motors, these 2507s. I recently tested a Gorilla 2507, and pretty good size for 7-inch props. So these 1800, it's gonna be pretty good for those 6 and 7-inch builds. Seems those are kind of becoming popular again, and or even you can use 6 or 5-inch on 6 or 5S. So this, I imagine, are gonna be quite versatile. Same thing for the 2407s. They should be able to drive those props. So interesting sizes. Looks like BrotherHobby is once again bringing some interesting motor class. So we'll see how these perform. So as usual, they come in these not fancy boxes. Nothing wrong with that. Keeps the price low. They both look pretty similar, actually, as far as the color scheme on the motors. It's pretty much the same. They're almost indistinguishable. You have to look at them close, and so to look at the size and the labeling. But they're pretty much identical. As you can see here, you can just barely see the size difference there. Pretty cool color, I think. Black and this reddish color on top, and this time as you can see, it's a totally different pattern, the spoke pattern on the bell cap. It's quite different. Looks like they're, because it's a large size motor, looks like they're going for a very light bell cap. As you can see, these are minimalistic spokes on this bell. So they're also using these white wires for the motors, kind of different looking, and pretty good gauge. This is 16 gauge wire, so fairly thick wire. So it should be able to handle any current that the motors are drawing from the battery. So the motors are pretty much full of all the features that we've come to expect from BrotherHobby. N52H arc magnets, 0.15 millimeter silicon steel, Kawasaki silicon steel on the laminations, the stator laminations. They're using single wiring, high temperature wiring on the windings. The bearings, it looks like now they're all the new motors that BrotherHobby is manufacturing are coming with ISO 8x4x3 bearings, and also the shaft. This is supposed to be titanium alloy. The base casing and the bell cap, this is all aluminum 7075. So the strong aluminum. It's not gonna strip that easily here, and it's gonna resist impacts much better. It's a stronger aluminum. As I said, these wires are pretty thick. So these are 18 gauge wire, but they should look like 16. The wire length is 160. Pretty good length. Hopefully it's enough for a 7-inch arm. So let's see what it weighs, and that's with the wiring. And as always, I'll weigh a amount of wire that if you cut it, these are cut to 50 millimeters. So we're gonna get the equivalent weight. So if we cut the wires to 50 millimeter length, we'll be getting rid of about 5 grams. So this wire's pretty heavy. So that's 5 grams. So let's see what this one weighs with the wire. So that's gonna be, this is the 2507, 40.9. So 41 minus 5, that's 36 grams. So 36 grams for the 2507, and for the 2407, the 2407 is 39.6. So minus 5 grams, that's 34.6. So 34.6 for the 2407. Pretty decent weight for a 2407. And also not too bad on the 2507 at basically at 36 grams. I mean, there's some motors, some 2306 motors that are just as heavy almost. So very light for this size motor. So they're using a hex screw to retain the shaft. So you can see there's also a brass washer there. They do have a thread lock. So to remove them, the best thing to do is to use a soldering iron and then just leave it on there for. I just left it for about 5 to 10 minutes, just making contact like that. So that softens the thread lock pretty well, and then you can easily loosen the screw and remove it without messing up the head of the screw, because with the thread lock, since it's such a small Allen key you have to use, I think this is 1.5 millimeters. So there's a good chance that if you don't do that, you're gonna round it from trying to knock it loose. So the best thing to do is just put the soldering iron there for 5 to 10 minutes. It's not gonna damage anything. It's just gonna heat up the screw and the shaft, and it heats up the whole motor, but not a lot. I mean, the motor gets hotter when it's operating. So after 5 to 10 minutes, you can just easily loosen it. Then you could just remove it. So let's get it on the magnifying glass so you guys can have a closer look. Okay, so here's the bell cap. Pretty cool patterns here. The design of the bell cap and the spokes is pretty cool looking. There's the shaft. It's 4 millimeters titanium alloy. So you can see the magnets are not overly thick, and their spacing is kind of normal. Also, the air gap is not overly tight, but it's not loose either. So I'm hopefully this will be a very smooth motor. So usually smooth motors won't give you like a super high thrust, but when you're in transition, you know, going back and forth on the throttle, just because of the way they've arranged the magnets and the stator and all that, you know, just the way it works, you get really smooth transitions. So meaning the motor doesn't jerk, so you end up with a very smooth overall build. So here's the stator. As you can see, typical from BrotherHobby. Super neat windings, and those are the 8 millimeter by 4 by 8 by 3 bearings. Seems that all the motors are coming with this size bearing. Okay, so here's the stator. As you can see, in typical fashion from BrotherHobby, pretty neat windings. There's the 8 millimeter diameter bearing, 4 millimeter inner race, and it's 3 millimeter depth. So smaller bearing. They're going with this bearing for most of the new motors. So I imagine that saves weight, and maybe it allows better distribution of the copper on the stator, because, you know, it's a smaller diameter bearing, so you end up with longer coils here. So I imagine, you know, it allows you to put the wire better distributed. So I'm not sure if that's helpful for motor performance, but I don't know, just an idea. And there's the laminations. These are 0.15 millimeter, and this one is 7 millimeters, so no surprises there, right on the nominal height. and the base pretty looks like it's pretty beefy. So you can see nice and thick base, and that's the 2506. The 2407, it's pretty much the same. I mean, they're using pretty much the same layout, the same construction. Although the wire looks a little bit different. As you can see, this is the 2407 on the right. So just different coloring on the wire. Just don't think that means much. Just different enamel. Same height on the stator. So basically the same construction, just smaller, just different dimensions on the stator itself and on the bell here. But it's pretty much the same. Here's the 2407 on the right. So pretty exciting new motors from BrotherHobby. Alright, so we'll put this back together. So Avengers assemble, and we'll put them on the thrust stand and see how they perform on the thrust stand. Alright, so here are the thrust test results for the BrotherHobby Avenger 2507 2700 kV. This motor measure at 2660 kV, pretty close to the spec 2700 kV value. One thing I want to mention about the amps is that don't be alarmed that they seem to be quite high, but that's kind of typical from static thrust tests. You gotta keep in mind that in static thrust the motor and the props are not moving, so they're gonna be grabbing a lot more air than if it was moving through the air. The other thing is also that I use a little bit higher starting voltage compared to the other 4S tests where they use 14.8, which is the nominal voltage, 3.7 volts per cell. But the reason I keep using 16.1 is because that's what I had been using before. Back in the day, I was using a battery bank, 8000 milliamp hour battery bank. So I would charge the batteries. It was two batteries, two large batteries in parallel. So I would get them fully charged, and so I ended up with 16 volts after a couple of runs. The batteries would start losing voltage and just kind of settle at 16 volts. So that's why I kept using 16 volts, so that I could always go back and compare to my old test. And I just kept using 16 volts. Perhaps one day, eventually, I'll lower it to 14.8. Not sure if I'm gonna do that, but if the motors keep getting this powerful and as current demanding as these ones we've seen in recently, I may have to lower the voltage to 14.8 so I don't blow my equipment. That's the one thing I want to mention. So don't be alarmed by the very high amps. When you fly these motors like this, or any 2207 with a high kV, when you fly four of them being supplied by a single battery, the battery is going to be the limiting factor. It's going to limit the current to whatever it can supply. So if the battery can only supply 200 amps in a short burst, then that's the max you're going to see altogether for all your motors. So that's one thing to keep in mind. So I'm only testing these 10 props right here, but I'm sure this motor can match very well with many other props, but these are the only ones that I have on hand that I thought would represent the performance of the motor pretty well. Doesn't mean that other props are not gonna be better or match well. It's just that these are the 10 props that I chose, and due to time constraints, I really couldn't test any more props, as I have a few other motors waiting to be tested. So I had to limit the test to these 10 props. This should pretty much give you a good idea of what the motor is capable of, and let you compare them with other motors that I've tested in the past. I thought this would be a good bunch of props to test. Alright, so with that aside, let's look at the results. I included this 5045 prop, just kind of curious to see what it would do with a motor like this, and as you can see, almost 1700 grams. So that's pretty interesting to see this prop making that much thrust. Then we move on to the tri-blade props, easily clearing the 1700 grams for the 5043x3. And as we go on to the heavier props, more aggressive 5-inch props, they easily clear 1800 grams and almost 1900 for these XT 5045. So pretty amazing power out of this motor. Of course, as I mentioned, the amps are going to be quite high, so you'll definitely need a very good battery to get the most out of this motor. As we move on to the 6-inch props, I did test the 6045 on 4S, so 2082 grams. The rest of the props I went on 3S because the amps were getting too high for my equipment. The SC I use is it's rated at 40 amps, but it can take pretty high burst, as we can see here, and also the current sensor is only rated to 50 amp continuous, so I guess it's able to survive these high bursts. But I don't want to press my luck and blow out the equipment. So I went back to 3S here for the rest of the test. The tri-blade 6-inch props, pretty decent thrust on 3S, and then the 7-inch props also pretty high thrust on 3S. This 7040, from what I hear, it flies pretty decent, but it's a little bit unresponsive on hard maneuvers, so that's something to keep an eye on this 7040. And this 7045, as you've seen, is pretty much similar to the 6045, but just an inch longer. Usually HQ props are pretty good quality, so that's one prop that you guys might want to use on if you're gonna use 7-inch props. But anyway, I think this motor might be perhaps a little bit too high kV for a 7-inch. I don't know if you guys are gonna be using this on a 4S 7-inch quad. The motor could probably can do 4S on a 7-inch prop, because as I mentioned, the props are gonna unload in flight, so the amps are gonna be a lot lower. They could be up to 35 or 40% lower once you get flying, so it should be able to handle 4S on these props. Alright, so that was the thrust test and review of this motor. Hope you find the data useful, and Thanks for watching, and until the next video.